so this is the last page of the notes packet that you picked up on Wednesday. So the first page was solving the radicals algebraically, and then I showed you how to confirm them graphically. And then the second page of the notes was finding inverses graphically. Now this last page is going to be finding the inverses algebraically. Okay, so we've got steps here for you to review. Okay, you were going to replace f of x with y. So if it's written as f of x, just think of that as y. And then remember, we said that inverses x and y switch. Okay, so you're going to take your x and y and flip them or switch them in the equation. And then you're going to solve the equation to get it in y equals. Then once you do that, you replace that y again with f inverse of x. Remember, this is the notation for an inverse function, is to have that little -1 up there in that superscript. Okay, so f inverse of x is how we read that. Now it says sometimes it's helpful to use the domain and range of the original function to identify the correct inverse function. And that this happens when you get a plus or a minus case in the end. Okay, so we'll look at that when we get to one of those. So in number 1, it says to find the inverse algebraically. Okay, so we're going to go through those steps that we just listed. Okay, and then we'll take a look at the graph like we did with the previous set of notes. Okay, so the first thing we're going to do is switch x and y, because it's already written as y instead of f of x, so I don't need to replace that. So I'm ready to switch x and y. So I'm going to say, okay, this is x equals the square root of y minus 1. Now I want to get this in terms of y. I want y equals. So I've got to get rid of that square root, get rid of that radical. And remember, in the first set of notes from this packet, we said to solve a radical equation, you raise it to the power of the index. So this is a square root, so I'm going to square both sides, because that square, or this radical is already isolated on one side. And it's a good idea to get in the habit of using parentheses there. They don't really make a difference in this particular case, but they could if there was more than one term over here. So the square root and the square eliminate, and I've got y minus 1. So now I'm going to add 1 to the other side. And so now I've got it in y equals. And this is the point where now I replace y and use the correct inverse notation. So that is the inverse function. Now, let's look at the graph of that. Okay, if I graph the original function, let's do that. Do the original one in green. So this square root function is shifted right 1 from the parent function. Okay, so I know that it's going to have the vertex. Oops, get out of here. It's going to have the vertex at +1, because it's the opposite sign to get your h, and then there is no k. It's an understood 0. So I'm going to start at 1, 0. Oh gosh. Okay. And then the a is an understood 1. So we know that there's no stretch or compression or reflection. Okay, so I'm simply going to then, from my vertex, go over 1 up 1, go over 4 up 2. Or you could go over 9 up 3. So there's that function in green. Okay, now I'll take what I just came up with here, the inverse function. You can call it inverse y since we used y there. It doesn't really matter. Is x squared plus 1. That would have a vertex. Let's see, there's nothing inside with the x, so that h is a 0, and then a plus 1 on the outside, that's your k. So 0, 1. Notice your x and y flipped. That's what they should do for inverses. So we have a point at 0, 1. Okay, and then we know that in a parabola from the vertex, you go over 1 up 1, or over 2 up 4, or over 3 up 9. And here's the right side of that parabola. Now, the way the equation is written, the equation doesn't say to limit the domain. So if I were to actually graph the rest of this, I would need to reflect it over here and show this side of the parabola. But I know that's not actually the inverse of this square root function because it didn't have it down here. So I don't include that half. I don't do this part. Okay, so if you want to do what I did and show it scratched out so you know that you don't include it, you can do that. Okay, so I'm going to make some notes down here by B. So it says, what do you notice about the two graphs? Are they reflections of each other? Again, I'm going to put that line, y equals x here as a dashed light gray line. So we can see those definitely look to be a reflection of each other across that line. Okay, but that's after we scratched that out. Okay, so maybe I shouldn't have that scratched out yet. Let's answer some questions just based on graphing. Get back to pink. Let's say we did graph that entire parabola. And let's answer the questions in terms of that. Okay, so the way that it's written, I would say no. They're not reflections. Okay, is the inverse a function? Yes, that parabola, that is a function. Do we need to restrict the domain? Okay, and the answer here is yes. We don't need to restrict it for it to be a function. It's a function whether we restrict it or not, but we should restrict it to x is greater than or equal to 0. Now I'll do that scribbling out of the left side. For those to actually be reflections of each other, we need to restrict it and not include the left side. So technically, that should be written as f inverse of x is x squared plus 1, where x is greater than or equal to 0. That's how we need to write it. That's how you write the restriction of the domain, so that it only shows the positive half, the right half of that parabola, so that those are a reflection. Okay, and then C asks, what is the domain and range of the original and its inverse? So again, let me zoom out a little so we can see the graph. So I'll do the original in green, the domain of the original function, left to right, so that was at 1, so 1 to infinity. So x is greater than or equal to 1. And the range, how low? 0. So it was y is greater than or equal to 0. Now, if you look at the new function, we just said the domain is restricted to x is greater than or equal to 0. And notice that was the range. So what was the range became the domain. And what was the domain, that becomes the range. And you can see, you can confirm that graphically. The lowest that goes is the y value of 1. So that's in the inverse function. That's in the original function. Okay. So let's flip that over and try one more. It says, what would happen if the original function started as a quadratic? So that's what we did graphically already. I showed you on the previous set of notes, we looked at the one that the graph started as the quadratic. And then when we found the inverse, we realized, oh crap, that's not a function. We need to restrict to make it a function. So let's look at that algebraically. So if I am going to solve this by switching x and y, again, f of x, that's the same thing as y, and I'm going to switch those. So it's going to be x equals y squared plus 2. And I want to solve for y, so I'm going to subtract the 2 to the other side. So I have x minus 2 equals y squared. And then to get rid of the square, the opposite operation is to square root. So when I take the square root as a step in solving, what we have gotten drilled in our heads, what we've been saying all year, is when you take the square root, don't forget your plus or minus. Okay, when you take the square root as a step in solving, you put the plus or minus. So we have plus or minus the square root of x minus 2, and that's what equals y. And again, when I write that in the proper inverse form, so f inverse of x is the positive or negative square root of x minus 2. Now, it says to graph the original function and its inverse. So the original function is the quadratic. So we know that the quadratic has a vertex. There's nothing in parentheses with x being squared, so h is 0, and then your k plus 2 on the outside. So vertex at 0, 2. And then your a is an understood 1, nothing there, so it's just got the normal over 1 up 1, over 2 up 4, over 3 up 9 would be off the graph. And then those are reflected across your axis of symmetry. Okay, so we've got our parabola, our quadratic. I'm going to sketch the line y equals x. So there's two ways to go about graphing the inverse. You can do what we did before on the previous notes and simply take all of these points and switch the x and y's and graph them. Or since we now have the equation, since we solved it algebraically, I can just use what I know, the vertex of a square root function, the opposite of this, because this is x minus h, so my h is actually positive 2, and there's nothing added or subtract on the outside, so my k is 0. So I know there's a vertex at 2, 0. Okay, and then the a is an understood 1, but notice it's positive and negative. So it's positive and negative 1. So we're going to graph it the positive and the negative. So there's the positive square root but we're also going to graph the negative square root, which is that reflected. So that's the positive and that's the negative. I graph both because when I did the step in solving, I have to put plus or minus in front. Okay, so those are inverses of each other. Okay, are they reflections of each other? The answer here this time is yes. Is the inverse a function? This time your answer is no. Fails the vertical line test. Okay, and then do we need to restrict the domain? No. The domain of the inverse is 2 to infinity, no matter what. Whether we restricted the domain of the original, the domain of the inverse would stay the same. Okay, there's no need to restrict because the graphs are the same shape. They actually are reflections of each other. Okay, if you flip back to that previous example, we had to restrict because they were not reflections of each other. They were not the same shape. This one was a full parabola and this one wasn't. Okay, so that's why we had to restrict that one to get them to be the same shape, to get them to be reflections across the line y equals x. Here, they already are the same shape. They are reflections, so I don't need to restrict it, but I do need to note that it is not a function. Okay, I need to make sure that I understand it is not a function, that inverse. And then again, they're asking for the domain and range. So for the original parent, or not, excuse me, it's not the parent function, but the original quadratic function, the domain was all real numbers. Range, the lowest that goes is 2. So why is everything greater than or equal to 2? And then on the inverse, your domain and range should switch. So you can see on that one, oh, I should put domain. My domain, it goes from 2 to infinity. So x is everything greater than or equal to 2. And this time my range is all real numbers because as this goes to the right, it's going down. And as this side goes to the right, it's going up. So it's going down and up forever. So your range is all reals. So again, notice with inverses, the domain becomes the range. The range becomes the domain for the inverse. They just flip. All right, so we've now looked at algebraically and graphically looking at inverses of square root functions. And we know that it's the quadratic and the square root that are inverses of each other. Okay, but depending on which direction you're going, you may need to restrict the domain of that inverse. Okay, so keep those notes handy with you as you do the practice over these. Okay, check your Canvas calendar to check and make sure you're completing all of your practice and assignments.